Hello friends, this is Bidhan. Welcome you to my channel. Today we have a problem from csirnet physics from June 2016, question number 39, booklet code B. Given the input voltage Vi, which of the following waveforms correctly represents the output voltage V0 in the circuit shown below? This is the circuit. We have to find the V output, where Vi is the input signal, and this is the symbol that our input signal is sinusoidal. That means oscillating character. That means it is AC signal, and this signal Vi has also been given in the problem. This is the Vi with time. You can see at time t equal to 0 the voltage is 0, and after a time the input voltage becomes maximum 0.5 volt, and then after a time it becomes 0, and then after a time it becomes minimum minus 0.5, and then after a time it becomes 0 again, and it goes like this: maximum 0, minimum 0 again. That means our input voltage Vi here is changing with time. It is not constant. It is different at different times. Now this circuit is having one more voltage, input voltage of 0.5 volt, and this is constant. This is the DC volt. I can say this is the voltage from a battery. That means this circuit is having two inputs. One is Vi, which is oscillating, and another is 0.5 volt, which is fixed. What is the output V0? And there are four options, and each option is oscillating output voltage. The first option says that our output voltage is oscillating between 1 and 3, and the mean voltage point is 2 volt. That means at time t equal to 0 the voltage is 2, and then after a time it becomes 1 volt, which is negative, which is minimum, not negative, and then after a time output voltage becomes 2 again, and then after a time it becomes 3 volt, and then after a time it becomes 2 again. So again it becomes minimum 1 volt, and then again it becomes 2, then again 3, then again 2. It is like that. This is the first option. The second option shows that the output should be oscillating between 0 volt and 2 volt, where 0 volt is the minimum and 2 volt is the maximum, and the mean voltage of oscillation is 1 volt. And the third option shows that the output is oscillating between 2 volt and 0 volt, and fourth option shows that output is oscillating between 3 volt and 1 volt. So which one is the right answer? We have to find. Now this circuit and the input signal, this one, those that have been given in our problem, I have also drawn on my board. So here is the circuit that has been given in our problem. What is the output we have to find? Now to write down the output formula, first of all we have to recognize the circuit, because if we don't recognize the circuit, whether this is inverter or non-inverter or differential amplifier or differentiator or integrator or logarithmic or whatever it is, if we don't recognize, we are not able to write down the output formula. And if we are not able to write down the output formula, how could we find out the output voltage? So that's why first of all we have to recognize this circuit, and clearly this circuit is differential amplifier circuit, because we can see two input voltages. This is possible. Two input voltages are possible only for differential amplifier circuit. We know this. So this is the differential amplifier circuit. What configuration? With open loop or with feedback? This is the differential amplifier circuit with feedback. Clearly we can see here is a feedback circuit. So two input voltages, 4 resistors and feedback. And we can also see that in our last video we had derived the output voltage formula for differential amplifier with feedback, and there we saw that resistances R1, R2, this is called R3 and R4. And we also saw that this resistance is generally equal to this resistance, and always in practical circuit this resistance is equal to this resistance. So this is equal to this 5K and this is equal to this 10k. Two input voltages, so this is clearly differential amplifier with feedback circuit. And we know what is the output voltage formula for that. The output voltage is R2 by R1 into V plus minus V minus. R2 is what? This is R2. This is R1. This is R3, R4. But we had derived and we had seen that these resistance and this resistance have no role in the output voltage formula. So finally, we understood this is the differential amplifier circuit with the feedback, and this is the standard output voltage formula for differential amplifier. This can also be written RF because this is the feedback resistance, but here I am just writing R2. What is V plus? V plus is the voltage whatever which is available to the positive terminal. That means this amount is now the V plus. And what is V minus? V minus is the voltage whatever which is available to the negative terminal. That means Vi is now V minus. That means Vi or V minus is what signal? This signal that has been given. This is Vi. That means V minus. And it is oscillating with time. And we can see that this is 0 at time t equal to 0. This input signal Vi, or I could say V minus, you may say V minus or you may say Vi. Okay. Now this signal is actually this signal. The V plus signal is constant. It is always 0.5, but this is changing. Changing in what way? It is 0 at time t equal to 0, and after a time it becomes 0.5, and then it becomes 0, then it becomes negative 0.5, then it becomes 0 again. Now here one thing, that these green lines, these dotted lines I should say, these dotted lines have no use here. They are insignificant. The reason is, in our problem there has not been any mention about these dotted lines. In our problem it doesn't say that between two consecutive lines there is a time gap of 1 second or 2 seconds or anything like that. It has not been mentioned anything like that. So that's why these lines are insignificant to write down, and that's why let me erase them. So I have erased them. Now we have our pure input signal, and here we can say one thing, that this is one complete oscillation going from 0 to maximum, then 0, then minimum, then 0. And what is the time taken by one complete oscillation? Capital T. So in the time graph, let us put capital T for one complete oscillation, the time taken this much from here to here. So obviously time taken for this much oscillation is T by 2. So the time taken for this much oscillation is what? Is T by 4, and at this point time is 0, and at this point the time is 3T by 4. That means the voltage is minus 0.5 at 3T by 4. The voltage is 0 at the half time period. The voltage is maximum at quarter time period T by 4, and 0 at 0, and 0 at the time period T. That means our signal is changing with time. It is, the signal is at T by 4, at T by 4 this voltage is, let's say at T equal to 0, at T equal to 0 the voltage is 0. At T by 4, at time T by 4 the voltage is maximum 0.5. The voltage is 0.5 volt maximum. Then at T equal to T by 2, what is the voltage? 0. Then at T equal to 3t by 4, what is the voltage? Minus 0.5 volt. Minus 0.5. And then at t, what is the voltage? 0 again. That means this input voltage is changing with time. At t equal to 0, 0, then quarter time period it is 0.5, then t by 2 it is 0, then again it is then minus 0.5, then at time period it is 0. In this way. Now we have to find the output, and output we will find by using this formula. So let us find the output. Now one thing is that there is a problem in finding the output, that when I will use this formula where V plus and V minus are there, V plus is always constant but V minus is changing. That means I have to find out the output at different times, at different time intervals, or at different instances. So let's find that. So first of all, the output at t equal to 0, at t equal to 0 second, what is the output? The output is V output equal to R2 by R1, that means 10 kilo ohm by 5 kilo ohm, into V plus minus V minus. And what is V plus? 0.5 volt, minus V minus. And what is V minus? At t equal to 0, it is 0. So 2 into 0.5, that means 1 volt. Then next we will find output at t equal to quarter of the time period. Then output is, again we will use the formula R2 by R1, V plus minus V minus. So it is 10 k ohm by 5 k ohm into V plus at time t by 4, it is again 0.5, because it is always 0.5. If I draw a graph of this, then what will be the graph? If this is time and this is V plus, the graph would be like this. If it is 0.5, it is always 0.5. So it is again 0.5 volt minus V minus is what? At t by 4, it is 0.5. Now they cancel to make 0. So it's 0. 2 times 0, that means 0 volt. Then next, let us find output at t by 2, half of the time period. Output is again R2 by R1, that means 10k by 5k into V plus, it is always 0.5, minus V minus at t by 2 is what? It is 0. So it is 0. Now this is 2 times 0.5, that means 1 volt. Then let us find the output at t equal to 3t by 4. So what is the output? The output would be 10k by 5k into R2 by R1 into V plus minus V minus. V plus is always 0.5 because it is DC, minus V minus at 3t by 4. So what is the V minus at 3t by 4? We see at 3t by 4, the V minus, that means this voltage, is minus 0.5. That means at 3t by 4, this time at this instance, the voltage is negative 0.5. So it is negative 0.5. That means it is 2 times minus minus plus, and 0.5 0.5 1 2 volt. Then let us find output at t equal to capital T, that means at time period. Then the output is V naught is equal to, again, R2 by R1 into V plus minus V minus. So R2 by R1 is 10k ohm by 5k ohm into V plus is always 0.5 volt minus, what is the voltage? V minus at t equal to capital T. So at capital T it is 0 again, the voltage is 0, and I have written here that at time t equal to capital T the voltage is 0. So let's write down 0. They cancel to make 2 into 0.5, and it is 1 volt. Now if you follow the outputs 1 volt, 0 volt, 1 volt, 2 volt, 1 volt, and when the outputs are there at t equal to 0, at t equal to t by 4, this is at t by 2, and this is at 3t by 4, and this is at t, this is 1 volt. Now let us draw the diagram for our output. Let us say this is V output, and this is the time diagram. So let us draw a graph of output time, output versus time. Now if this is time, this is t equal to 0. So this is t equal to 0, and let's give it this point 0.5, this point 1. Okay, I have to take a larger scale, otherwise it will not be sufficient. So let's have let's take this point as 0.5, 1, 1.5. No, I cannot give this, and this is 2, this is 0, and this is minus 0.5, and this point minus 1. So like this we have, let us say, now let us follow. At t equal to 0 we have, at t equal to 0 we have the output is 1 volt. That means the output voltage is 1 at t equal to 0. So from here let us draw, let us take our time scale. So this is the point at t equal to 0 we have 1 volt. Then at t by 4 we have 0 volt. So our output is 0 at t by 4. That means this point. And then at t by 2 output is 1 volt. So let us say that at t by 2 output is 1 volt, and this is 1 again. And then at 3t by 4 output is 2 volt, so it is 2. This point. And at 3t by 4 we have 2 volt, and finally at t we have 1 volt again. This is the point. So what we need to do, we need to this is the This is the reference for 0 volt, this is 1 volt, this is 2 volt. Now we can see at t equal to 0 it is 1 volt, and then at t by 2 it becomes 0 volt. So the graph is going like this. Then at this is t by 2 and this is 1 volt, and then at 3t by 4 it is 2 volt, and it goes like this, and then it goes like this. Okay, so finally we have the graph. So we have our graph. Now we can give references of 1.5 volt also, it just doesn't matter. For 0.5 volt they are useless. So this is the graph we have, and from this graph if we compare with our given options, then which option is the right option? Here we can see the oscillation is between 0 and 2. The minimum value is 0 and the maximum value is 2, and the mean output voltage is 1 volt. So from 0 to 2. And we can see that if we see option 3, the oscillation is from 0 to 2. But there is a problem that it starts here and at t by 4 it goes to 2, but here at t by 4 it goes to 0. Now if you see our option 2, it totally matches. How? It starts from 1, at t by 4 it goes to 0, then at t by 2 it goes to 1 again, and then it goes to 2 at 3t by 4, then comes to 1 again at t, and this is what happens here. It goes from 1 to 0, then 1 again, then 2, then 1 again. So this matches with this option 2. So our answer is 2. Thank you.